For centuries, the English Channel was a moat that kept Britain safe from ground invasions. When World War I broke out, the sky didn't seem much more threatening. The airplanes of the era were fragile, underpowered machines, barely capable of lifting a pilot and a rifle. But a retired German army officer named Count Ferdinand von Zeppelin saw a different future for aviation. He believed the sky belonged to massive, controllable airships. He achieved this scale through a precise engineering leap, the rigid design. Unlike a deflating blimp, a Zeppelin was built around a lightweight duralumin skeleton. Inside this metal ribcage, engineers packed multiple internal gas cells filled with highly flammable hydrogen to provide immense lift. By 1910, these engineering marvels were flying thousands of commercial passengers safely across Germany. But when war erupted 4 years later, the military rapidly adapted their heavy lift and long endurance to create the world's first high-altitude strategic bombers. The ocean no longer provided an absolute sanctuary. For the first time, an airship could drift silently over a city in the dead of night, targeting its interior while borders remained uncrossed. Starting in January 1915, Germany sent these leviathans across the North Sea to strike at Great Britain. Drifting over cities in the dark, they dropped incendiary and high-explosive bombs onto the population below, earning a dark nickname from the terrified public, the baby killers. The British military quickly scrambled to stop them, only to discover their defenses were completely ineffective. When British fighter pilots actually managed to reach the high-altitude airships, they emptied their machine guns into the massive targets and watched as absolutely nothing happened. The physics of the encounter favored the Zeppelin. Conventional solid bullets simply punched tiny, neat holes straight through the outer fabric and the internal gas cells. The hydrogen leaked out slowly, but without a spark, the massive craft wouldn't catch fire. The Royal Flying Corps realized they were up against a weapon that could loiter over their own capital and drop payloads with total impunity. They needed a specialized tool to bring them down. The solution required understanding the specific chemistry protecting the airships. Hydrogen gas is highly flammable, but it cannot burn on its own. It requires a specific mixture of oxygen to ignite. Inside those massive gas cells, it was pure hydrogen. At the high altitudes where Zeppelins operated, there simply wasn't enough atmospheric oxygen mixed into those isolated cells for a spark to actually catch. To solve this, British engineers in late 1916 developed a lethal two-part ammunition sequence. They loaded fighter planes with alternating rounds of Pomeroy and Brock bullets. The Pomeroy was an explosive round. Detonating against the Zeppelin, it tore a gaping hole in the cell wall, violently mixing escaping hydrogen with atmospheric oxygen. The Brock incendiary round arrived a split second later, flying into that highly combustible cloud and delivering the fatal spark. This precise 1-2 punch effectively weaponized the Zeppelin's own lifting gas against it, turning an engineering marvel into a chemical death trap. But having the right bullets was only half the battle. A pilot still had to find a silent, dark target drifting thousands of feet in the night sky. To track them down, Britain rapidly built a sophisticated home defense grid around major cities. They deployed giant acoustic sound locators to listen for the engines, and batteries of anti-aircraft guns, and deployed massive searchlights to illuminate the sky. This coordinated ground network created a hostile zone that forced Zeppelin commanders to fly much higher to survive. At those extreme altitudes, the fierce winds and freezing temperatures ruined their navigation and completely destroyed their bombing accuracy. Trapped in the blinding crosshairs of searchlights, the airships were now visible targets for fighter pilots. Using the new ammunition, a single burst of fire was enough to incinerate the massive structures in seconds. Following heavy, fiery losses through late 1916, the German military realized their strategic bombers were too vulnerable. They abandoned air raids over Britain, pulling the surviving Zeppelins back to conduct naval reconnaissance over the North Sea. This chart reveals the paradoxical impact of the bombing campaign. The direct physical damage was relatively small, resulting in roughly 550 civilian deaths and £1.5 million in property damage. But the strategic military impact was massive. To protect their citizens, Britain had to divert hundreds of artillery pieces and vital fighter aircraft away from the Western Front, keeping them trapped at home. The rigid airship saw a brief, glamorous revival in the interwar years as commercial passenger liners. However, the catastrophic combat losses of World War I proved the fatal vulnerability of hydrogen, accelerating the rapid advancement of higher-flying, faster airplanes that quickly left the giant airships obsolete. The brief deployment of the Zeppelin destroyed the illusion of the island fortress. It demonstrated that a nation's civilian population could be reached from the air, making the home front a permanent theater of war.